Okay, so we have set it up. We have integrated. The 1/5 just kind of stays out front. We got to plug in. So 1/4 times 5 to the 4th minus 2 times 5 squared plus 5 minus, what am I going to get when I plug in 0? I'm going to get 0. So I'm going to do that. Just be careful. Don't do that whenever you've got trig or exponentials or logs, really. Although if you're doing natural log of 0, you're going to get it undefined, so it'll probably be an issue. But if it's just a polynomial function there, you're just going to get 0. So I just need to, now on an FRQ, I could stop here, right? So if this was an FRQ problem, we could stop. Let's go ahead and simplify like it's not. So, oh gosh, that 5 to the 4th. Maybe I don't want to. Let's see, 25 times 5 is 125. 125 times 5, 625, yep. So we've got 1/5 times 1/4 times 625 minus 2 times 25 plus 5. So 1/5, and I've got 625 over 4 minus 50 plus 5, so we're looking at 1/5 times 625 over 4 minus 45. And then I guess I want to do some common denominators. So multiply by 4. 45 times 4 is going to give me 2016 180. So I got 1/5, 625 minus 180. So 625 minus 180 is going to be 445. So I've got 445 over, I'm going to go ahead and do 20 because it'll be over 4, but you'll multiply it by the 1/5. Those are definitely, actually, let's, hold on, I'm going to back up. Those are definitely divisible by 5. Let's do it like this. I got 445 over 4 times that 1/5 right there. I could reduce right here. Ugh. 5 goes into that 8 times. 9 times 89. So we would get, we're going to divide by 5 here, divide by 5 here, you get 89. So 89 over 4. Again, on a free response, you can and should stop here unless you need it for some other reason. Like if you need to be able to tell if this number is higher or lower than 0 or something of that nature, yeah, go ahead and continue, but otherwise, don't simplify on those. Okay, questions there? So if you see the phrase average value, you need to be thinking 1 over interval and integrate the function that they're talking about. Okay, position, velocity, acceleration. There, I tried to cover several things that I think you may see. One question that they give a lot is the particle moving away from or towards the origin? Sometimes it's not the origin. Sometimes it may be a different point. It might be like x equals 2. You guys had that weird one a little while back where it was like you had 2 different points. If you're talking about if points are moving towards or away from each other, you have to consider position and velocity. Okay? The reason that you have to consider position is, I guess I should write it up here, is this right here. If velocity is positive, particle is traveling to which direction? The right. And if the velocity is negative, particle is traveling to the left. Okay, so imagine that we have particle A and particle B, right? If A is moving to the right, so like in my mind, if they have opposite signs, they're moving, in my mind they're like moving towards each other. But A is moving to the right and B is moving to the left, they would be moving towards each other, right? But what would happen if it looked like this? What if B was here and A was here? If A is still moving to the right and B is moving to the left, are they moving towards each other? They are not. So I would, when I consider position, I draw it on the number line, right? And if you're talking about the origin won't be moving. It'll just be sitting there, right? And then your point is either moving towards the right or the left, but it depends on where the point is at, right? Because if another option would be like if I have this, like let's say our particle moves to the right. If the particle A starts right here and moves to the right, it moves away, right? But if our particle A is right here, moving to the right, it moves towards the origin, right? So for towards or away from an origin or a point, you have to consider position and velocity. Two things. Every time you have to know those things, and you have to mention them in your explanation. Does that make sense? The other question that you see that's kind of similar to this is they will ask if speed is increasing or decreasing at a given time. Okay, so typically we think about acceleration. If I have positive acceleration, that means my velocity is increasing, and I think about that being as like the speed increasing, right? Because in real life we don't really think about velocity very much. Like if we're thinking about driving a car, we're thinking about speed. We don't really think about our direction so much. But you have to have velocity and acceleration, because all of the car driving things you're thinking about going forwards. You're thinking about accelerating forwards. You're not thinking about going backwards and what it means to have like negative acceleration if you're going backwards. The best way to keep this straight is that if velocity and acceleration have the same sign, the speed of the particle is increasing. And if velocity and acceleration have different signs, the speed of the particle is decreasing. Okay, so towards or away from the origin or towards or away from another point, position, velocity. You got to consider both of those. Speed, increasing or decreasing, or sometimes it'll say speeding up or slowing down. That's velocity and acceleration. You got to know both of those. The other things that you get asked a lot are, how far did the particle travel from t equals a to t equals b, right? So from time 1 second to 7 seconds, how far did the particle, oh, I really should have written this differently. I'm pausing here because what I have failed to do right here is make a good worksheet for you. Because how far did the particle travel from A to B? In that blank right there, I was going to put the word displacement. Does that necessarily mean displacement? I've used this example many times. You go out the door, want to go to the bathroom, you go down to the bathroom over here, they're cleaning the bathroom, you have to walk all the way back over to the other bathroom, right? Your displacement is just from here to the bathroom where you're at. Your total distance traveled is further. So we really should reword this, and I should add something else. Now that I'm filling it in, it's making sense that why I need something else here. So, how far away is the particle from, or like at t equals b? How far away is the particle from its position at t equals a? Now, sometimes displacement and total distance are the same. Sometimes they are exactly the same. That would be if you only go in one direction. So if you leave my room and you just walk straight down to the bathroom down here past Miss Martin's and you go there, and you don't have to go anywhere else, then your displacement is the same as your total distance traveled because you only went in one direction. But if you change directions, that's when you see that they're not the same. So it really should be worded more like this: at a certain time, how far is the particle from where it started at t equals a? This can be given in a lot of different contexts. It might be, driving along a straight road. There's your home that you're going like towards or away from, whatever. This is displacement. And again, I think it did this weird thing. I don't think I did this where it has that box when I initially typed it. I think it's where I opened it up and it wasn't there. And so for displacement, you are going to have this integral here. Just integrate velocity, right? It'll take care of itself. Displacement is just the integral of velocity. But if the particle changes directions, then it's not going to do that. So for total distance, I should add in, here I'm going to add this in. Let me go back. And you guys maybe can squeeze this in down there at the bottom. What is the total distance that the particle traveled from t equals a to t equals b? Which is really more what I had on that first question, which was not right for me to do. Now, if you see this, here, this, actually, I'm gonna take the word total out here. This is total distance is what I'm going to put in these blanks and fixing it so I can do it next time. I really should change this. This is distance. Sorry, really messed this one up. And here we will do the integral. What do we do differently if we want to do total distance? Absolute value bars. So from A to B, we would have absolute value of dt. I don't want that underlined there. That's a big turtle. This is. Okay. Both of these right here will be like a during a time frame. So it's going to be like from t equals A to t equals B. It is a time frame from 2 o'clock to 4 o'clock, or from 15 seconds to 30 seconds, right? Whenever they say give the particle's position at, or given that the particle's position at t equals 5, what is the particle's position at t equals a value, c, whatever we have here, right? So this is asking you for the position at a single time. So it's not a time frame, but a specific instance of time. Okay. Whenever we integrate, it just tells us the amount traveled over a time frame, but we don't know where the particle started. Okay. So if you're asked for position at a specific time, you have to have a starting point. So it has to tell you that the position was whatever it was. I put t equals 0 is 5. It could be at t equals 2, the particle's position is 7, something like that. You must have a starting point, and your position is going to be whatever that starting point is. Right, like here, that 5 is your starting point. Plus displacement. Not total distance, but displacement. So we want to know where the particle's at, not how far the particle has been. So that would have been better if I had my stuff straightened out a little bit more, but hopefully that is helpful. Now, I have done everything here in terms of velocity, position, velocity, acceleration. But all of this also applies if you have like the rate at which the water in a tank is changing, right? They give you an equation for the rate that the water is changing. Well, that's like having velocity, right? The rate is like the velocity. So if they say that, what is the total amount of water that is added to the tank? Well, then you can do the integral of, technically, I guess it could be absolute value. In most cases, you don't need the absolute value because it's a positive rate, but we would have that there. So we're going to spend the rest of the time working on